A warm, hello everybody. A warm welcome to all of you. Now let's start the session. First of all, let us look into the agenda of this particular session. Throughout this course, we'll understand what are containers, what is a Docker, and we'll understand why do we need this Docker. After that, we will do lot of Docker daily operations like creating containers, deleting containers, attaching, starting, stopping, all the operations that are related with the containers, Docker containers. And then we will create a Docker image. We'll understand what is a Docker image and we will create a Docker image. Now, once we create multiple containers, we have to understand how to do the networking with containers, okay, or networking with Docker. We'll understand that, and we will see how to store data persistently, okay, that is by creating something called as volumes. So we will see about Docker storage, and then we will look into some advanced concepts on Docker, like Docker file, creating our own images, etc. And then we will understand about a Docker Compose. Docker Compose is like if I want to create 3 or 4 containers at same time, we can use Docker Compose. We'll install Docker Compose. We will see how to work with that. And then we will see one real-time project where we will install a complete application with multiple containers. All right, this is the syllabus or the agenda for the next couple of sessions. We will complete details about Dockers, and then the last section would be about interview questions and answers and assignments. All right, let's start our discussion with Docker. First of all, let us understand Docker overview or why do we need Docker, etc. To explain this concept better, let me shift to my whiteboard. Now, let us understand first of all in an application deployment. Okay, let us understand where Docker comes in an application deployment. Let's say there are multiple stages for an application deployment. Let's consider design is one stage, development is another stage, deployment is another stage, and let's say test or release. There are a lot of other stages. I'm just limiting it to 4 stages. Let's say these are the, let's consider these are the multiple stages that we have for an application deployment. Now, where does Docker come into the picture? Okay, this is where in an application lifecycle, this is where Docker operates for deploying an application. Now, why do we need Docker when we are deploying an application? Without Docker, can't we do it? Of course, without Docker also we can deploy the applications. But let us try to understand some problems, what the industry is facing, and why, how Docker is solving that problem. Okay. Now let us say I have developed an application, or let's say my team has developed an application. And there is one developer, he deployed the application. Okay, he deployed the application on his server. Okay, This is working, there's no problems. Now, where it is deployed, let's say he deployed on his some laptop, it is working, or some environment. Now, there is another employee, okay, he is also part of dev team, okay. He in his system, he deployed this application, but it's not working. Now, why? Both the employees have deployed the same application, right? But for one person it is working, for one person it is not working. What could be the reason? The reason might be, okay, now let's, if at all we look into an application itself, okay, what does an application have? Now we can simply say application is nothing but a piece of a code, right? Or we can say application is nothing but a code which has multiple layers. Now, what are the layers? There could be front end components, okay? There could be a back end workers or a database, and every application requires some environment, or it requires some libraries, or it requires some dependency files for that particular software to work. We'll understand a little bit about dependencies in next 5 minutes. Okay. Now all this together, if I put all this together, then I can call this as a application. That means now this person, this developer, something is missing here. Some dependency or some library is missing on his laptop. That is the reason this application is not working. But for this fellow, it is working fine. Okay. So this is one of the problems that industry has faced. That means if the application is installed on multiple platforms, it is not behaving in the same way, because dependencies are installed separately. He has some dependencies which this fellow does not have, and application is installed separate. Now, if I package this application, that means what? The front end code, back end code, database, environmental variables, and dependence, everything if I package, and if I put that package, it will work anywhere, because it has the dependency files, it has the libraries that is required for that code to work. Okay, this is one problem that is in industry has solved with Dockers. Okay, we'll understand little more in few minutes, but let us try and understand another problem that Docker has solved. Now another problem that it has solved is, let us say I have some computing environment, let's say it is a virtual machine. What will be there on that? Let's say there is hardware. On top of hardware, obviously we know there will be an operating system. Okay, and let's consider I want to install one Node.js application. Okay, if I want to install a Node.js application, what do I need on my server? Okay, I require some dependency files. I require some libraries for my Node.js to work. What it could be, let's say for a Node.js application, right? I might require something like a uh, Express.js. Okay, I'm just giving examples here. Okay, I might require some other softwares like let's say we have to install we might have to install a main server file, like a JavaScript file, okay, like something called as server.js. Okay, I'm just saying that we need some libraries, and we need some dependencies software for this Node.js to work. And we also have to install Node.js itself as well. Okay. All right. Now I have the dependency files. I have the libraries that are required for this to run. Okay. That is good. Now let's say on this particular server, I want to install another application called as MongoDB. Now this MongoDB also, it also requires a different set of libraries. Sorry, it also requires a different set of libraries, and it also requires a different set of dependency files, right? Now let's say another application like something like messaging or something like caching, some third application. Now this third application also requires some libraries. It also requires some dependencies. Now let us say, for example, this Node.js, okay, I want a library with version, let's say 1. The same library for messaging, I want a version 2. Then which version I have to install? Version 1 or version 2? Which one will work? It will not work. So on one system, I cannot have multiple versions, right? It might be a problem for us. Or else for this MongoDB, I want to install Mongoose client. That is a dependency if I want to access the MongoDB. All right. Now, that means every application has its own libraries, its own dependencies. Now, if I do like this, right, now every other application requires different libraries and different dependencies. Now, if I install or deploy all these applications on this server, they might work, they may not work because I already have Node.js with some version, version of a library. If I want to install this and if I want a different version of library, same library, different version, it will not work because it does not have the required library on this hardware. Now, this is also one problem. Now, how to solve this problem? By a software called as containerization. Now, what does this mean? Now, the same problem, let us say I'm taking a Node.js application. Let's say a Node.js application, and this Node.js application, let's say it requires some libraries, it requires some dependency files, okay, and there is some code. Let's say if I create a container, okay, with all the application code itself, libraries, dependencies, and code. Now, if I put this package on a hardware, on any server, will it work? Obviously, it will work because to run this application, if whatever is required, I have everything here. Now, let's say this hardware is Windows, it will work. Now, let's say if I'm putting on Linux, it will work. Let's say if I'm putting this container on Mac, it will work. If I'm putting it on Ubuntu, it will work. Why it will work? Because to run this application, I require this file, this file, this file, and everything is there together. Now, wherever I'm going to deploy this application, I'm not only deploying the code, I'm also deploying the required files for this program or an application to run. Okay. Now let's extend this example a little bit. Let's say we created a container. Let's say this container is Node.js container, and we have the dependency files that are required, dependency files, and the libraries that are required. Now, what is the other application here? MongoDB, right? So I'll create another container. Let's say this container is application for MongoDB. Okay, and MongoDB requires a different set of dependencies. Okay, MongoDB requires a different set of dependencies, and it requires a different set of libraries. Now let's take another application. Let's say the messaging application. This messaging application requires a different set of dependencies, different set of libraries. Now what I did, application, and what all the files and libraries that are required, we are boxing it together. Okay, so that that box can work anywhere. So we can say that a container is a sandboxed process running on a host machine that is isolated from all other processes running on that particular host machine. Now, where will be all these three containers? These three containers will be there on a host machine. Now, what will be there on the host machine? As usual, there will be hardware, and as usual, there will be operating system. On top of that, there will be another layer. This layer is nothing but Docker engine. So on this host machine, we are sandboxing a process so that whatever process that is running in this is isolated. So this container, it does not bother about this process, or it does not bothers about the dependency files, libraries that is part of this particular container. Okay. Now we can also say this as this process is isolated. Okay. This process is basically isolated from all of, if you consider this as MongoDB as one process, this process is isolated from this process and this particular process. Now this isolation, how it works? It basically works with two concepts which are there on Linux from very long time, which is called as kernel namespaces and C groups. Okay, these are the two process which is there in Linux from very long time. Now, by using these features, we can isolate the processes that are running on the host mission. What is the host mission? This is the host mission. Okay, so we can simply say that a container is a runnable instance of a image. Now we can say that if I have to define, we can have multiple definitions. One of them we can say container is a runnable instance of a image. Now, what is the image? We can create this complete process as a one image. So now, if I run this, this is there on this host machine, right? If I run this on another host machine, it will give us the same output. If I run this on another host machine, it will give us the same output. So we can say that a container is a runnable instance of a image. Now, what all we can do with the container? We can do multiple things. One is we can start, stop, create, move, delete. So these are the operations with the container. Now, how will we do this? Either starting or stopping, creating, moving or deleting by using a Docker API. By using a Docker API, or we can just do that by using a CLI, which is command line interface. Okay. Now, where can this container run? The container can run basically on a local machine. That means I can, on my laptop, I can install Docker software and create a container and run it. We can also run it on virtual machines. We can create a virtual machine on any of the cloud and we can do that. Or we can also deploy the containers on the cloud. Okay. Now, one more feature of the container, we can say that it is portable. That means, let's say this is one virtual machine. This is one virtual machine. I created a container here. We can put the container from here to here without any issues. And it can run on any OS. The container can run on any OS because the container has application code, libraries, and the dependencies that are application required to run. And it is isolated from other containers and it runs its own software, it runs its own binaries, configuration files, etc. Okay, that is what a containerization is. Now look, let us look into the our presentation and let's see what's there in that. Let me shift to my presentation. Now, as I told you, a container, we can install multiple applications, right? We can install a web server, database server, messaging, and let's say Ansible. Now, every application requires its own libraries, its own dependencies. It requires a different kind of OS, okay, and hardware infrastructure. This is a problem, okay. Now, what we can do? We can simply create this as a each application as one container. Now, Node.js has its own libraries. MongoDB has its own libraries and dependencies. Similarly, other applications. Now, on the same host machine, where there's a hardware infrastructure, on top of that, there's an operating system and a Docker image, and we can create multiple containers, and each container will work independently. Okay. Now we can say a Docker is a containerized or containerization technology. Or you can say Docker is simply a tool for creating and managing containers. Okay. We can simply say Docker is a tool that is used for creating and managing containers. Now we can also say a Docker is a standard unit of software or a package of code and dependencies to run that code. For example, if there's a Node.js code, it the container has the code also, it has the code runtime also. Okay, all this included in a container. The same container, if I create a container with let's say Node.js and Node.js runtime, right? This container always yields the same exact results, same application execution behavior, no matter who is installing it, where is installed, how it is executed, who is executing it, no matter, the result will be same because the container has the code and the runtime execution files, everything. Support for containers is built into modern operating systems. So now every modern operating system, there's a support that is built in for the containers. Docker simplifies the creation and management of such containers. So to work with this, to manage the containers, there is a software called as Docker. There's also other similar softwares like Containerd and Rocket are also containerization softwares. Docker is very widely used containerization software. If you're working with Kubernetes, we'll also there is also another containerization software called as Containerd. Okay, we'll also see that when we are learning Kubernetes. Now let's understand one more time about container. Now let's say there's a classic example. Let's say there's a basket, picnic basket. Now in this basket, there are dishes, there are food, there is spoons, forks, glasses, all the food is everywhere, right? Now this basket is portable. That means wherever I want, I can carry. Now it contains all the foods, all the dishes. We don't require any special environment or tools required. You can share it and use it wherever you want. Now, let's say I'm traveling in a bus. I can open this and eat because everything for me to eat is there. If I go onto a movie theater, if I want, I can open this and eat. So you can, anywhere you open and eat, you'll produce the same results because to eat the food, you require crockery and cutlery, you require glasses, everything is there in this basket. That is nothing but a container. A container will have the application code and it will also have the runtime dependencies and the libraries for the application to run. Okay, that is in short is a container. Now the question is, why would we want independent or standardized application packages? There could be multiple reasons because when we are developing an application goes us into multiple environments. Let's say for a developer, when he's building an application, there's a development environment. When a tester, there's a testing environment. For a pre-prod environment or a production environment. So the application code has to be deployed in multiple environments. Now, whenever we are deploying in a different environments, if the application code, if it does not have the required dependency files or required versions, right, it will not work. This is one of the problems. Like different development and production environments, different development environments within a team, clashing tools, that means clashing versions between different projects could also be a problem. So all these problems can be solved by using containers. Okay, so couple of more problems. Developer environment is often not same as production environment. A development environment for an employee A is not same for employee B. Tools and libraries required for project A is not same for project B, right? So if I install everything on one host machine, they will not work. So I want to containerize this application so that they can work on the same host machine. Now you can say that this can be achieved by virtual machines as well, right? Yeah, this can also be achieved by virtual machines, but there are some advantages of using a containers. Now let us discuss about containers versus virtual machines. Now if you look here, on the host system, you require a hardware infrastructure if you want to host container also, if you want to host a virtual machine also. For a virtual machine, there's a hypervisor layer like a Hyper-V, Citrix Zen, VMware. There's a hypervisor layer. It is also a kind of an operating system only. On top of this, we create virtual machines. Every virtual machine will have its own native operating system, and each virtual machine will have libraries, dependencies, and application is hosted on top of it. Okay. Now, if you look in this virtual machine, there is basically one, two, three operating systems are there. So the utilization of resources is a very high. Now, if you compare same thing, like if you want to install a container instead of a virtual machine, or let's say if you want to install an application on a container instead of a virtual machine, the utilization of the resources are less. Why? Because there is only one operating system on this particular host machine. And this container can pass the instructions to the OS with the help of a Docker engine. And one more main advantage of using containerization, you see the boot up, how much time it is taking. A container, if it has to boot, it is like it boots in milliseconds, very fast. Whereas an application virtual machine, if it has to boot, this would take about depending on what kind of uh, hardware that you're using, it could be 10 seconds, 15 seconds, or it could be about a minute. But a container boots are really fast. Okay, those are a couple of differences between virtual machines and containers. And let us see couple of more differences. A Docker, it has a low impact on OS, a very fast and minimal disk usage space. We can share and rebuild, and distribution is very easy in case of a containers, but in case of virtual machines it will be very challenging to share the virtual machines. Now, Docker encapsulate apps environments instead of the whole missions. So what does that mean? It only encapsulates, or it will only create bunch of files. Now, virtual machine encapsulates whole missions instead of just apps. So that is a huge amount of load if you want to port the virtual missions from one host mission to another host missions. Those are some of the differences between a containers and virtual machines. Now the question is, can I create a container on top of a virtual machine? Yes, you can do that. Now this is a host machine. You have a hypervisor. On top of that, I created a virtual machine. On the virtual machine, I have installed a Docker, and then I can install containers on top of a, or I can create containers inside a virtual machine. This is a better way so that we can manage the containers easily, and we can also configure high availability. If one virtual machine is going down, we can start the container in a different virtual machine. Now let us discuss about another keyword on Dockers, and that keyword is called as images. Okay, what is an image? Now if I have to create a container, where would I create a container from? I will have to create a container from a image. So image, with the help of image, we can create containers. Okay. Now what is a container? We can say a container simply it is a running unit of a software. Okay. And from one image, we can create multiple containers. Let's say container 1, container 2, container 3. We can create multiple images from one container. Now the top layer is a read and write access, and data is lost when we shut down this. Okay. Now a image, what does it contains? An image contains the code plus required tools for the runtime. Okay, it is a layer based, and the image is a read only. No application data is stored in the image. Whereas container will be read and write. Image is a read only. A container is a read and write. What does the image contains? Image contains container code plus dependency files plus the libraries. Okay. Now you see, as I told you, from one image we can create multiple containers. Now let's say I have this image called as Node.js. Now I can create this as container 1, container 2, container 3. So from one image, we can create multiple containers. Now, we understood the point that from an image, we can create a container. Now, where do I will get these images? Where do I get these images? These images, we can either use a pre-built image, which is there on a repository, one of the repositories which is called as Docker Hub. Okay, or else we can create our own image. How we can create our own image? By using a one very special file called as Docker file. Okay, that means if I want to create a container, I have to create a container from an image. Now, where do I can get images? Two options. One is pre-built images which are stored on the Docker Hub. Second is we can create our own images with the help of a Docker file. Now, as I told you, a image will have layers, right? What is the layers in the image? Now, the first one, as I told you, it will be a custom image. Okay, it is a custom image. On top of that, we can add, or else let's say we have an operating system that is a pre-built image. On top of that, we can install Node, that is one layer. On top of that, we can install a couple of softwares that we require, or the dependencies, that is another layer. So all these three, if I create, this will become as my custom image. So from a pre-built image, we can create our custom images. Where are the pre-built images? Pre-built images are stored in Docker Hub. Okay. Now, as I told you, a image is a read and only. Okay. An image is a read only images. Whereas a container, it is a read and write. So container is read and write. Images are read only options. Now, as I told you that we can create multiple containers from same image. Okay, from the image from one container, sorry, from one image we can create multiple images. Now we discussed that there is a pre-built images. Now where do we get this pre-built images? From a repository called as Docker Hub. We will see the hands-on exercise in the next chapter. So we will create a Docker Hub account. In the Docker Hub account, we have all the pre-built images. Or the other option is that we have to create our own images. And once I create our own image, we can push the image to Docker Hub. So it will be available for us whenever we want to use, or we can also share with our colleagues so that they can also use our image that we have created by our own. So now from a image, we create a container. Okay. And we can have, so from one image, we can have multiple containers. Now in this container, I can run a different code. In this container, I can run a different code if I want. Okay. We will see these commands in the next hands-on exercise. Now, basic commands to do the operations for containers would be Docker create, Docker run, Docker stop, start, Docker RM, Docker push, pull, build, and RMI. We'll understand all these commands in detail in the next chapter. Now, to recap, we have understood about what is Docker, what is a container, or what is an image, what is difference between a virtual machine and a container. Okay, these are the couple of things that we have learned in this chapter. I'll see you guys in the next chapter. Take care.